All right, here's a little video on 9.1, what is a solution? And the long story short, in 9.1, we learned that a solution is a homogeneous mixture. We reviewed what the word mixture meant. If you really need the review again, please feel free to take a look at my slides or take a look at Unit 1. And we reviewed what this word homogeneous meant, and we said that a solution is equal to a homogeneous mixture. Keeping it short, where homo means same, and so a homogeneous mixture is a mixture that is the same throughout. It means that it's all one thing. For example, sugar water. Sugar water, if you drink it, right, if it's stirred, the sugar has dissolved into the water, and thus it's one thing. It's sugar water. It's not sugar and water, right? It's just sugar water at that point. The first sip of sugar water tastes the same as the second sip of sugar water. It's all the same at that point. And so sugar water is a homogeneous mixture. It's a good example of it. And thus, therefore, because a homogeneous mixture is a solution, a sugar water is a solution. Okay. This is opposed to, if something is not a solution, it's not a homogeneous mixture, it's going to be a heterogeneous mixture or a heterogeneous mixture. Hetero meaning different. And what that means, therefore, a heterogeneous mixture is a mixture that has different parts. An example of this would be, I guess I didn't write it here, maybe I'll add this in as number 9, so take a look here. Sand water. If you put sand in water, right, you will have kind of two parts, right? You will have a sand part and a water part. It's not really sand water, it's sand and water, basically, right? So this is a heterogeneous mixture. It has two different parts, and therefore it's heterogeneous. Okay, so those are two examples. Now let's take a look at the rest of these examples and just try to work through and apply this definition of a homogeneous mixture, same throughout. That's what a solution is. Let's see what these things are. So salt water. What is salt water? Well, if you have salt, you put it into water, right? They will become one thing. It's no longer salt and water, it's salt water. It goes all together. We have a homogeneous mixture, and therefore it's a solution. How about black tea? What I mean by black tea is something like Earl Grey or English breakfast or, black color tea. What is black tea? Well, black tea, right? The first sip tastes the same as the fifth sip. All of them, it's the same throughout, and therefore it's a homogeneous mixture. And therefore it's a solution. Right, and so black tea is a solution. How about boba tea? Boba tea, right? The thing with boba, as you guys know, is it has little pearls. And so those things make it so that the fifth sip may taste different than the first sip, which may be different than the third sip. It's not the same throughout. There's like a boba part and there's a tea part. It's like boba and tea, they're separable. And so therefore, we say that this is a heterogeneous mixture. It is not a solution. Heterogeneous mixture, right? I didn't write that for number 9, right? But it's not a solution. And then orange juice with pulp, similarly, right? The pulp is, it makes it so that there's kind of like two parts, right? Like there's like the pulp and then there's the juice, and they're not really all together, right? It's not really mixed together. And so this is also a heterogeneous mixture. How about black coffee, right? You didn't add anything to this coffee. There's nothing in it, right? Just black coffee. That also is going to be, this is going to be a homogeneous mixture, right? Because it's all just one thing. The first sip tastes the same as the 10th sip. It's all together. It's just black coffee. It's one thing, right? And so it's a homogeneous mixture. Chili's an interesting one. All of these so far have been mostly liquids, but mixtures can be solids, they can be gases, they can be mixtures of solids, gases, and liquids, right? And so Chili is also an example of a mixture. Is it homogeneous or is it heterogeneous? Well, I'd have to say it's mostly heterogeneous, right? Unless you have like the most perfect chili, right? For the most part, there's like parts to chili, right? You could separate it out. There's like the tomatoes versus the onions versus like the peppers, right? And so cilantro, etc., whatever. You guys make, I'm sure people make great chili, which I don't know about. But the point is, right? There's parts to chili. It's not the same. It is a heterogeneous mixture. And then lastly, trail mix. Trail mix is kind of the same. Trail mix, there are parts to it, right? Sometimes if you grab a handful out of the bag, you'll get one with a lot of M&Ms, right? And that's the best handful when you have a lot of M&Ms. But most of the time you get, or it seems like you get just a ton of peanuts, right? And so what we see is that, one scoop versus another scoop, those could be very different. Trail mix is heterogeneous. It's not the same throughout. For those of you who like math, the law of large numbers means that if we have a large enough sample size, then it will be more so homogeneous. But with the small sample size that we have, as well as the largeness of our items, it's going to be heterogeneous. But interesting thing to think about if you like to just think about random science and math things. But anyways, if you don't, heterogeneous mixture, okay, keep it simple. So that's 9.1. What is a solution? Solution is a homogeneous mixture. We applied it to a couple different examples. That's all. It's pretty conceptual. This isn't a very difficult lesson. It's just, do you know the definition of a solution? Do you know that it's a homogeneous mixture? Do you know what that means? Do you know what a heterogeneous mixture means in comparison? So that's it. Hope that helps. Feel free again to take a look at the slides for some pictures and some review. But let me know if you have other questions outside of that.